Good evening, everyone. I am Emily Andrade, and let me now discuss to you the modified internal rate of return. So, what is MIRR? MIRR is the present investment plan that equalizes the latest value of the cash inflow to the first cash outflow. It is designed to generate one solution, eliminating the issue of the multiple internal rate of returns. It is used to rank investment of a project firm or investor may undertake. So, to calculate the MIRR, we will have to calculate the terminal value of all the cash flow. So, we have an example here for Project S that requires us to invest $1,000 at time 0. We will generate 500 in time 1, 400 for time 2, 300 for time 3, and 100 at time 4, with the required rate of return which is the 10%. So, in finding the MIRR, we have to calculate the TB for all the cash flows, cash inflows, and the present value of the cash outflow, which is the 1,000. So, the terminal value will be cash flow 1 is equal to 500 times 1.1 times 1.1 times 1.1, which will give us 665. So, we will do this up to cash flow 3, except cash flow 4 since it is at time 4, which is the terminal period, so the TB of the $100 will just be $100. So we just need to add them up to get 1,579.5 of the TB for this cash flow. So now, let's proceed in using the formula, which is the present value equals the terminal value over 1 plus MIRR raised to the power of 1 over n, which would be 1,000 equals to 1,579.5 over 1 plus MIRR raised to the power of 1 over 4. Using the algebra manipulation, we will get 1 plus MIRR equals to 1,579.5 over 1,000 raised to the power of 1 over 4. So, the MIRR will be 0.1211. We will just turn this into percentage, and the result will be 12.11%. So, looking back at the MIRR result, the 12.11% compared to the required rate of return is higher than 10%. So we will say that this project is a good project. Let's proceed now to the NPV profiles. NPV profile of a project or investment is a graph of a project's net present value corresponding to different values of discount rates. The NPV values are plotted on the y-axis and the WACC is plotted on the x-axis. So remember, this is a conventional cash flows where there's initial negative cash outflow but followed by subsequent positive outflows. So the 1,300 minus 1,000 equals to 300 will be plotted as the vertical axis intercept as shown in the figure 11.5. So there are steps in preparing the NPV profile. First, we need to find the NPV of the project S, which is the 78.82. And the second one is the IRR, which is the 14.49%. We need to remember that IRR is the discount rate that causes the NPV to equal to 0. So the discount rate at which the profile line crosses the horizontal axis is the project's IRR. When we connect the data points, we have the NPV profile. So this table shows the NPV profile for Project S. Let's now proceed on the next table. So this table shows the NPV profiles for Project S and Project L. So we can see here that the two NPV profile line cross at the cost of capital, which is called the crossover rate. So to calculate the crossover rate between the two projects, we need to first take the difference of the cash flows by subtracting Project S cash flows to Project L cash flows for each period. So we'll just take Project S initial investment minus Project L initial investment up to the fourth period problem. To calculate the crossover rate, we simply take the IRR of these differences by inputting the IRR formula in Excel. So 11.97 will be the crossover rate of Project S and Project L. This table will visualize the crossover rate on the NPV profile. This will be the net present value for Project S and Project L at different discount rate. We will put NPV for Project S and NPV for Project L. And then we will put 0% up to 20% discount rate, and then we will calculate the NPV. So we need to remember that we need to refer to the discount rate. So the formula will be equals to NPB A17, which is the discount rate, B6 to B9, which is the project S cash flow, plus B5, which is the time 0. So we will just do the same thing for project L. We can see here that project L and PB ranks higher, but project S IRR rank is higher, and if you look at the figure 11.5, and notice that IRR says accept if the project cost of capital is less than the IRR, and if the cost of capital is less than the IRR, the NPV will be positive. So by accepting project S and rejecting project L, S will have more funds to invest in year 1 because S has a higher inflow that year. The next one is payback period. Payback period refers to the amount of times it takes to recover the cost of an investment, or the length of time an investor needs to reach a break-even point. Shorter paybacks mean more attractive investments, while longer payback periods are less desirable. To calculate the payback period, you can use the mathematical formula, which is payback period equals to initial investment over cash flow per year. We're just going to calculate the running balance at each year for the both project. So we're just going to calculate the running balance at each year. So we're just going to equal this because that's what we're starting out with. So this will be C8 equals to C18 plus B19. After that, we're just going to look on what year we got started getting a positive cash flow. In the table, we can see between year 2 and 3, the cash flow is positive, so the payback period is 2 years and some fraction. To get the payback, we just have to put equals to 2 years, which is the A20 in Excel, plus C20. Since C20 is negative, we'll just have to put negative sign to make it positive, divided by B21. So 2.33 years is the payback for project S. So we'll just do the same thing to project L. Let's now proceed to the discounted payback calculation at 10% cost of capital. Before doing the balance for the discounted payback, let's do the present value of the cash flow first. The discounted mid-payback period that takes into the account, which is the R or the 10% cost of capital. So to get the present value of the cash flow, we just have to put the formula, which is equal to present value, B11, the 10% rate, A29, the number of periods, and B29, the cash flow. For the balance, we just have to put equals to D28 plus C29. For the discounted payback, this gonna be equals to 2 plus negative sign D30 divided by C31. And the result will be the discounted payback for project S. So we will just do the same thing to project L. For the conclusion on capital budgeting methods, we have discussed budgeting decision criteria, which is the NPB, IRRR, MIRR, payback, and the discounted payback. We could say that NPB is the single best criterion since it provides a direct measure of value the project adds to shareholders' wealth, while RRR and MIR measures profitability expressed as a percentage rate of return, which is useful to decision makers. And the payback and discounted payback provide indication of a project's liquidity and risk. In conclusion, the different measures provide different types of information, and all should be considered when capital budgeting decisions are made. For the decision criteria used in practice, the table shows that NPV criterion was not used before 1980, but by 1999, it was close to the top usage. Second, the IRR method is widely used but its growth is less dramatic compared to NPV. For the payback, it was the most important criterion years ago, but its use criterion had fallen drastically by 1980. So, we could say that NPV is the best single criterion, but all the methods are useful and provide information that is easy to calculate along with the judgment and common sense. That will be all. Thank you.